Hi, everybody. So Murph and Ava are outside, so they're out playing. Um, all right. So we're in section 5.4, and we're dealing with long division and synthetic division. So the first thing that we need to learn is that synthetic division will only work if you're dealing with a binomial as your divisor, and the binomial needs to be of the form x minus k or x plus k. In other words, your x's need to be to the first power. For long division, you can have x squareds and so forth. All right. If you have, for instance, x to the fourth plus 2x squared plus 3x minus 1 over x squared plus 1, and you're going to do long division. Well, you need to fill in any time that there is a missing exponent. See how it's 4 then 2? Well, there's a 3 missing. So we're going to fill in with a 0 there, and the same here. It's 2 and then it's blank. It's an exponent of 0 on the variable effectively. So we fill in with a 0. So if we write the long division problem for this, it's going to look like the following. X squared plus 0x to the first plus 1. And it goes into x to the fourth plus 0x to the third plus 2x squared plus 3x minus 1. Okay? So remember to fill in with your zeros whenever there's a gap in the exponents. Now, we are going to come over here and we're going to do the process. And I have it's a stupid way, and I apologize. It seems to stick. So when you're doing long division, you're going to do C, D, E, and F. Those are the 4 letters. So you're going to compare the firsts, then you're going to distribute. Evaluate? Not yet. You need to do Frankenstein first. Okay? So compare your firsts, distribute, evaluate, not yet, and then do your Frankenstein. And it all seems a little odd, but it's developed over all of these years, and so just I'll demo it in a second. Okay. We are going to divide 5x squared plus 3x minus 2, and we're dividing it by x plus 1. So x plus 1's on the outside, so it's down and out. Again, if you're feeling a little down, you're going out. Okay? And the first step is to compare your firsts. Now, bear with me. Here and there. And the question that you ask is, what do I multiply x by to make it exactly the same as 5x squared? Well, that's 5x. Okay? Now step 2 says distribute. So 5x times x is 5x squared. 5x times 1 is a positive 5x. Now the next step says evaluate, not yet. So we wait a second. We've got to do this thing called Frankenstein. And okay. So if I'm teaching the class, forgive me. I go, draw your line and change your signs. And I act like Frankenstein, and I walk across the room, and my arms go out, and I'm acting like my arms are drawing this line, and we are changing the sign. And the reason is because division is repeated subtraction. So if you can draw and imagine a Frankensteinian kind of dude here, and here's his 2 arms, and he's walking. Well, this arm is the division bar, and this arm is the not division bar, the line that you separate for the subtraction, and then this is the line of making negatives or changing the signs. I know it's stupid, but for whatever reason, it seems to stick with people, and so I'm sorry that I just did that to you, and it's going to stick in your head for at least the next couple of weeks. So now we can go ahead and subtract, and we get minus 2. And now we repeat the process, so we go back to comparing the firsts. So you ask, what do you multiply x by to get it exactly the same as negative 2x? Well, you'll multiply by a negative 2. Now we're going to distribute. So I have a negative 2x minus 2. Evaluate? Not yet. We've got a Frankenstein. Draw your line and change your signs. So now we get 0. Now you don't have to get a remainder of 0, but this one happens to be a case where x plus 1 is the factor of this. And so you can say the following. X plus 1 times 5x minus 2 is equal to 5x squared plus 3x minus 2. In other words, this is the factored form of this. So long division, effectively, is nothing more than factoring. Okay. Now we're going to do synthetic division. And I want to point out that this comes into here as a root. Okay? At x plus 1, that's a factor. But you're going to think about the zero product property and go, well, x plus 1 set equal to 0. Okay, if I set that equal to 0 and I bring the 1 across, I get a negative 1. So the process goes this way. You write all your coefficients down. Just ignore the variables. Just drop those off. If you have any zeros, you got to fill in your zeros. That's vital. Okay, and again, this only works if it's just an x minus 1 or an x plus 1 or that kind of thing. Bring your 5 down. All right, negative 1 times 5 is negative 5. I'll do that again. Negative 1 times 5 is negative 5. 3 and negative 5 is negative 2. Negative 1 and negative 2 multiplied together is a positive 2. We get our 0. Okay? So what that's telling us is, and this piece right here is our referred to as our reduced equation. We have 5x minus 2, and then this is x plus 1. So we're actually able to get our factors out of there. Okay, hopefully that's helpful. I'm running out of time, and I'll probably make a couple more of these just so you can see some more examples. All right, talk to you in a bit.